Hello, I'm going to talk about the problem I worked on recently. So the business problem I try to solve is a Chinese automobile company aspires to enter the US market and producing cars locally. They want to understand the factors on which the pricing of a car depends in the American market, since those may be very different from the Chinese market. Essentially, the company wants to know which variables are significant in predicting the price of a car? How will those variables describe the price of a car? Okay, so I need to model the price of cars with these attributes. It will be used by the management to understand how exactly the prices vary with the independent variables. They can accordingly manipulate the design of the cars, the business strategy, etc. to meet certain price levels. So based on various market surveys, a large dataset of different types of cars across the American market has been gathered. The dataset I have is having 200 plus observations of 26 variables. There are a bunch of categorical variables such as symboling, cylinder number, engine type, fuel system, fuel type, aspiration, door number, car body, engine location, driver wheel, etc. And there are a bunch of numerical variables as well. And the dependent variable which we want to predict is car price. So but the data set has some issues to deal with. There is a data preparation phase, like the car name variable is combination of company name and model name, but we are interested in just the company name. Okay, so by using gsub or stringr, the company name is extracted to convert and converted to factor. Second issue, all the company names are not spelled correctly. I mean, same company has been spelled in two different ways, such as Nissan with capital N, Nissan with small n. Third, there are no duplicate values. The missing values in the outliers are checked and replaced with median, and data quality issues such as having unacceptable values, such as having 8 doors are taken care. And next step in the data preparation was creating dummy variables for each categorical variables. One challenge here is that how do we deal with categorical variables having numeric values like number of doors? It has values 2 and 4. I choose to convert them as dummy variables. Otherwise, if we consider them as numeric variables, we are assuming a linear relationship between price and number of doors, which is really not the case. So with these steps, we have the data prepared. So next step is to model the data. So the data is divided into training and testing in the ratio of 80 and 20%. Since we want to predict the continuous variables and its relation with independent variable, linear regression is used. The predictive power of the model with all independent variables is quite high, but we want to further improve the model because there are many variables which are not contributing to the model. This is achieved by step AIC. Step AIC, it automatically rejects the statistically insignificant variables. It actually does that by choosing the least significant variable to drop and then reconsidering all dropped variables except the most recently dropped for reintroduction into the model. So the linear regression model is built again with the variables that are considered as significant by step AIC. Now to further find out the collinearity between the variables, VIF of each variable is considered based on the significance of the variable, that is p-value and VIF value. Variables having low significance and high VIF are removed. Again, build the model, remove the variables based on VIF and p-value until all the variables have less VIF and they are significant. But again, there, as we are about to reach the end of the modeling, we may end up with few variables which have high VIF and as well as they are very much significant. So in that case, I choose not to remove the variables because if we have less number of variables in the final stages of our modeling, uh, multi-collinearity might not be a big problem, but removing the significant variable just because it is having high VEF might might drastically impact the adjusted R square of the model. So coming to the model evaluation part, adjusted R square is the metric I use to evaluate the model because it gives the percentage of variation explained by only those independent variables that are in reality affect the dependent variable. On the other hand, R square, it gives the percentage of explained variation as if all independent variables in the model affect the dependent variable. So the adjusted R square is close to 90%. That means the model is fairly powerful in predicting the car price. And the final variables that affect the car price are engine location, car width, engine size, company name, BMW and Buick. These two car company also has very very much impact on the car price. Yeah, so that's about the project. Thanks.